so everybody, first thing I would do with this is realize it says find f. It gives some conditions that have to do with the final function, not the derivative. So you still have to find the general antiderivative. Again, I start by thinking of the problem this way. I do not want to deal with quotients. So now I will add 1, right, to the powers. And you get 2x squared over 2 minus 3x to the negative 3 because you add 1 over negative 3 plus c. All right, so we got this plus c. All right, and now we have this beautiful condition. If x is 1, the result is 3. So I'm going to do this 2 steps at a time. The 2's cancel. I get 1 squared minus 3's cancel. 1 to the negative 3 plus c. Guys, 1 squared minus 1 to the third over 1 to the third, negative exponent with 1 doesn't matter. You get the constant is 3. So my final equation for number 26 in the book is f of x, in black, f of x equals x squared plus x to the negative 3 plus 3. I guess I wouldn't write it as 1 over x cubed. You could, okay? You could write it as 1 over x cubed at that point, but I'm not going to, yes.
So the f of 1 equals 3. You put the 3 in for f.
Yeah, because remember, this is y, this is x, and remember, this is y, right? Yeah, so 3 equals, yep.
Okay.
All right, so here, I'll pause the video again. Why don't you try 28 and 30. Now, be careful, 30. I didn't give you the first derivative, I gave you the second, and I have 2 conditions to help you get there, all right? So try 28 and 30.
He's not here today.
All right, we're on YouTube. Be quiet. All right. So, everybody, again, my suggestion is don't worry about the c right away. Add 1, and everybody, it's not negative 3, it's negative 1, right? Because you add 1, it goes up plus c. All right. And now, if I want to find c, I will use a condition. And I'm a little confused why there's 2 of them, so I'm going to probably want to check them both, because that's what it gave in the textbook. So it's 0 equals negative 3 over x plus c. And I know right now when x is 1, all right, so I put in 1, right? I get c is 3. All right, but here's the problem, everybody. What happens if I put in negative 1? Guys, if I put in negative 1, I get c is negative 3. All right? So the question becomes is what does that mean, right, for this function? Is it 3 or negative 3? Or is it both of them? All right, well, there's 2 conditions up here. And when you plug in 1, when you plug in x is 1, we're getting c is positive 3. When I plug in x is negative 1, I get c is negative 3. I get 2 different constants. So everybody, guess what?
Calculator.
No, it's not a calculator. All right, and I'm going to erase this to give myself some room. So everybody, this is a piecewise function, right? It has 2 different c values. All right? And it can be written this way, guys. It can. And here's the only part, is I'm going to have to guess where the split is. I would assume because 1 and negative 1 are symmetrical, the split is on the other side. All right? So this is negative 3 over x. I got to get some more room. So you got negative 3 over x plus 3 when x is greater than 0. You have negative 3 over x minus 3 when x is less than 0. And everybody, you know that 0 is not in the domain of this function. You can tell by looking at it. Is everybody with me? And we have a condition here, all right? This is a kind of a tricky problem. I would not put one of these on, but it's a piecewise. Guys, 30 is not too bad. It's all polynomial. So again, I would start by doing the first derivative, adding 1. It's 4x minus 6x squared over 2 minus 40x to the fourth over 4. You can see that they made this problem pretty. It's plus c. I would reduce it at least this much. I would get 4x minus 3x squared plus 10x to the fourth plus c. And then it says, hey, when the first derivative is 0, you get 1. So c is 1 for the first derivative. So I'm going to cheat. I can see that. I'm going to cheat on the eraser board, and I'm going to put the plus 1 in. Now, jump up another order. 4x squared over 2 minus 3x cubed over 3 plus 10x to the fifth over 5 plus 1x over 1 plus c. And everybody, it is, and I got to stress this to the nth degree. Guys, I gave you the y-intercept again. I'm not going to plug it in. C has got to be 2. C has got to be 2.
Hey.
And everybody, there's a polynomial, 2 derivatives. So everybody, you have to have 2 conditions. Now, where would this problem get really nasty? It would get really nasty if I gave you 2 conditions, if I didn't give you the first derivative condition, and if I plug in 1, f of 0 is 2. If I tell you f of 1 was, let's see here, 2 minus 1 is 1, plus 2 is 3, plus 1 is 4, plus 2 is 6. If I give you 2 initial conditions, you would have C1 and C, right? And you'd have to solve 2 equations with 2 unknowns. And now we will head to that, but again, initially we give conditions for each derivative. But if you're on the second derivative, you just need 2 conditions, guys. And then you should be able to solve it.